Cool. Let's just see how. Yeah. There's someone watching. So, hello. I'm Matt. I hope you enjoyed the jazz music, courtesy of YouTube's free music library for YouTube videos, which is awesome. So what is this all about? So I'm Matt. I do things on the web. I work for Google, though this is not strictly a Google thing. And I'm going to be... I've watched a lot of live coding sessions, and there are things that I like and things that I don't like. And one of the things that I really like in a live coding session is watching whoever's coding not know what they're doing. People who, when you see them solve a problem, rather than just show you how they previously solved a problem. So sometimes you see a live stream, and it's done live, but it's been rehearsed, and all the problems have been found before. And you see what the solution is, rather than how they got to the solution. So I'd like to do something a little bit more raw, and I'm going to code something from scratch that I haven't really looked into. I haven't really figured out how to do. Now, I said in my tweet about this that I was going to do something useless, and that's deliberate so that we don't get bogged down in the thing that I'm making, but rather how I go about it. But I decided that what I was going to do, this internet thing, right, what it needs is a way to have animated images. So why don't we take this brand new GIF 89 spec and implement GIFs on the internet? Not GIFs, GIFs. Or GIFs, as I heard someone say. So I've loaded up the spec for GIFs, and I've had a quick look through it to see roughly how it's organized so that I'm not completely lost. But I haven't actually looked at it in any detail. I don't know how a GIF is encoded. I know that it uses LZW compression, but I don't know really how that works. So we might spend a lot of time doing that. I seem to remember it's a relatively easy one. We'll see. I've implemented deflate before. I think that one was more complicated. So this should be fine. Yeah. So I guess let's just get started. I do have the live chat open. It is 90 degrees away to this side from where my camera is. So I'm going to be alternating between my screen and the camera. I might not see the live chat very much, but I'll try and have a look around there. I see there are a couple of comments about the music. And we'll see. I guess we'll just see what happens. This is a bit of an experiment. I deliberately did this kind of last minute, and I tried not to get it too well publicized, because I didn't want hundreds of people turning up thinking I was going to do something really polished. So bear that in mind. This is just something I'm doing on the fly. Okay, so I've loaded up Visual Studio Code. I have a web server running on a folder, and I was going to say there's nothing in it, but it currently has a cat GIF in it, because we need a GIF to work on. This is one I just found on the internet. So we need some code, I guess. So let's start with index.html. Oh, I've just realized this is not the computer I normally use. It's not going to have any of my snippets, so I'm going to actually have to type all of this myself. Doc type HTML, because we are good citizens. Let's bump that up a bit. This is an HTML document, and it's going to have a head, the title that says GIF. Oops. That's kind of all we need. And we're going to be using JavaScript to decode GIFs, so I need to load some JavaScript. Script source equals GIF.js. And I guess we need that JavaScript file. So far, so trivial. Now, so if we have a look over at the spec here, when I was flicking through the spec, I found it to be a little weak in its organization. So it starts by giving details about particular blocks, and then later goes into like which blocks do. It's in the wrong order for someone to actually implement this. So there may be a bit of scrolling backwards and forwards here, but I did find towards the end here the grammar of a GIF. And a GIF data stream begins with a header, and if we look for header number 7, apparently, it's 6 bytes, a signature, and a version. So let's load up our GIF. Zerma, I much prefer indenting with 2 spaces, but this laptop has defaulted to 4, and I don't want to fix it on the stream. So it's going to annoy me as much as it annoys you. Don't you worry about that. So let's can't type fetch. Let's fetch our cat GIF. Promises. So I'm working in Chrome, and this is kind of an experiment. So I'm just gonna go ahead and use all the latest and greatest features. So I'm gonna create a begin. I say I'm using the latest and greatest features, but I immediately started by not using our arrow function. Async function begin. So we're going to await the fetch of the cat GIF, and then autocomplete, brilliant. Array buffer dot slice. Wait, no, not the. So and then the actual data equals dot array buffer. Await that. And we'll call this buffer. And then we should be able to have a look and see what the first few bytes. We'll see what the first few bytes of this file are. So I'm going to create a uint8 array. It's just going to be a throwaway. New uint8 array. Because I know that they're 3 single bytes, 2 sets of 3 single bytes. That's what it said in the spec. 3 bytes. So I'm using uint8 because that's byte sized, and I'm just going to give it the buffer. But I'm also going to say offset 0, length 6, and then we're going to console.log the array. Let's see what we got. Oof. Should probably have started Chrome at least once before I began the stream. Nothing is what I've got. Why is there nothing in... Oh, I didn't call begin. That'd be a good start. No, it hasn't updated. Saved. Ugh. Okay. What's that when it's at home? Okay, so if I do, probably don't need to do a lot of text stuff, so maybe I'll just do this in the console. Const decoder equals new text decoder. UTF-8 decoder.decode this thing. Just give me a temple. GIF 89A. Okay, that's a good start. So we loaded up the file and it really did start. Oh, yeah, okay. Yeah, everything bigger. Oh, that's probably too big. I actually just want to make the font bigger, not the... hold on a second. Settings. There we go. I don't want to make the UI massive, just the font. How's that? I think there's quite a lag between what I see and what you see, so I'll have a check in the chat in a minute. That looks good to me. Yeah, I can almost read that on the preview window I've got here, and it's tiny. Perfect, cool. So we loaded up the file, we got up some data, it appears to be what we were looking for. This is a great start. So let's start making an actual parser. So what I want to do is build a data structure with all the information from the GIF. And I probably want an individual function for each part of the data. So, I mean, there's in a GIF, there's multiple images, and there's like color tables, and there's things like that. So I probably want to like read color table, or read image data, or whatever there is. So I guess if I've got some data and some code, that's going to be a class. That's GIF. You know what? I am going to change. No. Indent. How do I change the size of the indent? Oh, there we go. Re-indent lines. There we go. I'll have this take the buffer. And then begin parsing. So stop parse header. That's what it was called, wasn't it? Parse header. So header bytes equals I'm going to say 0. I'm going to say that the functions take the current position in the buffer, just in case you can have a header halfway through a file or something. It shouldn't hurt. And all the other functions are going to need this because there will be multiples, or I won't know statically where they're going to arrive. They could be somewhere in the middle of the stream. So the header bytes is going to be new int 8 array. This buffer position 6. I know their header is 6. How am I going to return the new position? Oh, either I return the new position or I have a position field. We'll come to that. We'll come to that. So I then just, for the header, I don't actually need anything from this. I'm just going to check it. So I'm just going to check. So if how do I compare two arrays by value? Or what's the best way? Okay, so I'm going to have a constant header, and we already saw what this should be, because I don't want to decode it into a string to do the comparison. It seems a bit wasteful. I don't need it as a string. Reslice the buffer with the remainder. The buffer is always all the data, so I can so the what are they called? Typed arrays. You can take a slice of that buffer. Oh no, I guess you're right. You can you can reslice the buffer. You can take a slice of a buffer. Maybe. We'll come to that maybe later. I guess what I really need is this would work well as a stream. This would work pretty well as a stream and as a state machine, and actually do a parser that way. But for now, I'm just going to pass positions around. A lot of parsers do it that way. So header is that. Let's just go for the simplest thing that could possibly work. So let match equal true. For I think this one has to be like equals 0, 9 less than header length. I don't even need this. I don't even need this because if header bytes I not equals header I, I'm just going to throw an error. Now, looking at the spec over here, there are actually two possible headers. 87A and 89A. But really, if you're still using the 1987 version of GIF instead of the 1989 version of GIF, I'm prepared to ignore you for the sake of an experiment. View for the remain. No, I get it. Yeah. Sorry. I should probably say when I'm looking at the chat, because not everyone will be looking at the chat. If you see me turn all the way around, I'm probably looking at the chat. And Zema says has been talking about how I might manage my current position within the stream of bytes, perhaps by slicing the buffer or creating a view just for the remainder. And these are all good ideas. But I think I'm going to stick with the simplest possibility, which is just some number that says where I am, and I will, in each function, grab out the bytes that I need. I seem to remember that most of the sections that I'll be parsing will have a length, so I'll probably read the length and then read another typed array of the actual bytes, and then return the new position. Return the new position. We'll see. Okay, let's see what this does. Well, it will do nothing because I haven't told it to do anything. So I'm going to do. So this is the file. Const GIF equals new GIF buffer. It's not actually going to give me any output. So in here, just for testing purposes, header bytes. Oh no, GIF is not defined. What have I done? Oh. Okay, I like it when it's easy like that. Okay, so we're still reading the file, and I am going to return 6. Let position equal 0. Position equals. So what comes next? This is about as far as I've read in the spec. So what does come next? Where was the grammar? Somewhere near the end. Okay, so a logical screen comes next. After the header, a logical screen, and a logical screen begins with a logical screen descriptor. What's one of them? Logical screen descriptor. Logical screen descriptor. Contains parameters necessary to define the area of the display device within which the images will be rendered. This block is required. There will be exactly 1 present per data stream. This block must appear immediately after the header. And it looks like it's a fixed size. I don't see. There's no length here, so equals this dot parse. What's it called? Logical screen descriptor. Yeah, maybe I should be holding this state somewhere. I'm going to argue with myself all night with that if I don't just ignore it. Parse logical screen descriptor. I've been doing a lot of TypeScript recently, and it looks very weird not putting the return types and the types of everything. I figured that would be confusing in the stream. So if I accidentally type some types, that's what I'm doing, and hopefully I'll just notice that it's wrong pretty quickly. So this, let's copy this. Let's copy this into here. Oh, that's quite big as a comment. Just for now. Unsigned. How big is an unsigned? Is that an unsigned byte? Unsigned. Great. No idea how big that is. Oh, but So this suggests this is 8 bits, and the width takes up 2 lots of 8 bits. So an unsigned. Oh, this is like a C unsigned. It's a what is it? Short. Anyway, it's 16-bit unsigned integer. It also doesn't say what the endianness is, but I guess we'll load up the value and we'll see. It'll either look right or it will look very wrong if I get the endianness wrong. So let's do something like this. So position and how big is this? So this is also going to be 6 bytes by the looks of it. Yeah, it's fixed. No, hang on, 7 bytes. 0 to 6. But I don't want it as. I don't really want a uint8 array of this one, do I? So typed arrays are cheap because they don't actually allocate any memory if you pass in a buffer. They don't do anything. It's just a view. So I can create as many as I want without really worrying about it. And also, yeah, I'm not particularly worried about performance or anything right now. What's the column header says byte? Oh yeah. No, that I can see exactly why that would be confusing. But no, it doesn't even say byte. You're just wrong, Zona. You're just wrong. So I'm going to take these two as a uint16 array. That's interesting. This should probably be an int8 array rather than a uint8 array because it just said byte. No, hang on. Byte is unsigned. Byte is unsigned. Never mind. Yeah, there are no signed things here. So buffer position, and this is going to be is the length in bytes or in units? Well, we can figure that out as well. So let's say 4, and then just console log it. Descriptor bytes. Let's see what that looks like. 480, 480, 2470. So I suspect, yeah, since I've ended up with 4 things. So it must be asking for the number of items, not the number of bytes. And apparently this GIF is 480 by 480. Let's test that out. Let's see if that's likely to be true. Wah. Go. Let's inspect. 480 by 480. Okay. Great start. So we're going to have a width, which we'll just set something in the constructor, and then here we can say this dot, which one's first, width or height. Let's pull that off. Width, then height. This dot width equals descriptor byte. It's not really. They're not bytes. So I was just gonna, let's call that size. Size 0. Height equals size 1. And then after that, so I have these packed fields, but it is a single byte, and I have to mess around with it. So I'm just going to take out 3 bytes, and then we'll have to do some bit twiddling with that first byte to get the various information out. Color index, pixel aspect ratio, packed fields. So I'm just going to call this extra. It's another orientate array. It's the buffer. It's position +4, and I want 3 of them. Awesome. So what are these things? So the second one, background color index. And we've got pixel aspect ratio. Global. Just copy these. Ugh, key bindings, not what I'm used to. Apparently that's fine. I'm trying to take a shortcut, which apparently was in Sublime Text and not VS Code. This would just be quicker to type, wouldn't it? Quicker to stop being clever, Matt. So, list background color index equals extra 1. List pixel aspect ratio is extra 2. Now for this one, global color table flag. Global color table flag. This is 1 bit. I assume it's the first bit. Is it the highest bit or lowest bit? Flag indicates if the flag is set, the global color table will immediately follow the screen descriptor. Oh, hang on, we can tell because it's 1, 3, 1, 3, 1, 3, 1, 3. So this is bit 7. This is the high order bit. So that is it's going to be extra 0 logical AND with that's a bit 7, so that's x80 equals not x80. So that will tell me this. So we AND with not x80. That strips away any bit except the highest bit. So it will either, the result of this will either be 0x80, 128, or it will be 0. If it's 128, then the bit must have been on, and therefore the flag is true. Yeah. Oops. So we want to do something kind of similar for the other things. So sort flag is another bitwise one, and that's bit 3. Hang on, 1, 2, 4, 8. Okay. So yeah, so this will be exactly the same, except it's 0, 8. Color resolution. This one, we want 3 bits. It's actually, so it's a number between 0 and 7, I guess. Number of bits per primary color available to the original image, -1. Okay, so it's actually between 1 and 8. So we get this by, so we're going to do an and again, but we need 3 bits, and in this case it's actually just going to be 7, 0. So what this is going to do is strip away any bits except the ones that we're interested in. So bits 4, 5, and 6 will be left over, and then, but they won't be in the right position, so I will then shift them down 4 to get them into the 0 position. Yeah. And then with whatever this last one is, it's already in the least significant position. So we don't have to do the shift there. Size of global color table. It's not a very good name, is it? And this will be 0, 7. And we don't actually have to do anything with it after that. Cool. So let's output those. I seem to remember when we looked at this a moment ago, they were all 0. So this isn't actually very interesting. Yeah, they're all 0. Oh. Did I mean and? Why are these 7? Oh, hang on. No, 247. The flags are 247. Okay, let's see if that makes sense. So 247 to string 2. So our bits are global color table flag, true. Color resolution 7. Sort flag, false. Global color table size 7. 7, 7, true, false. Looks good. It was the other 2 bits of information, the background color index and the pixel aspect ratio, that were both 0. Okay, so I've got some information. We'll work out how to use that in a minute, I guess. Yeah, we'll read the details later. Not important. What comes next? Once we get a little bit further in, we'll actually start drawing it, and then we'll actually have to care about what the values were. For now. Global color table. Alright, yes. So in our case, the global color table is set. So we definitely have to read it, but it is optional. Global color table. Why is global color table not in the grammar? What? Oh no, I guess things like logical screen descriptor weren't either. They can't be. Okay, it's a terminal of the grammar. So global color table. Let's search for that. About color tables. That's a lot of explanatory information. There's a lot of reading. Oh, it's immediately after the last bit we were doing in the spec, which makes sense. This block contains a color table, which is a sequence of bytes representing red, green, blue color triplets. The global color table is used by images without a local color table and by plain text extensions. Whatever that means. It immediately follows the logical screen descriptor and contains a number of bytes equal to 3 times 2 to the power of size of global color table plus 1. So here, size of global color table. Number of bytes contained in the global color table. To determine the actual size of the color table, raise 2 to the value of this field plus 1. Okay, so the actual size is this plus 1. 2 to the power of something you can do with a bit shift. No, let's not do that. Let's keep this simple. Already got bit twiddling going on here, so it's math.pow. Oh no, hang on, is it to that? I feel like it's that, and it's 3 times that. Yeah, the new POW operator in ES 2017. I guess we'll see. If I've got it right. How long have we been going? Oh, almost an hour. So, yeah, let's just see what that number is first. Size of global color table 3. No, I've done something wrong, haven't I? 2 to the power. Oh. I bet that's it. I bet it's operator precedence. So the global color table 768. That sounds better. So that's 256 colors, 3 bytes each. So when we return from here, it's going to be position plus 6. Sorry, plus 7. We can get rid of that. Just realised I copied this in and then kept going back to the spec to look for the same table. So that was useful. So we have our first optional section. If this dot global color table flag global color table. So I guess we're going to have a dot color table. Because we might not have one, I'll set it to null in there. But I know that in the one image that we're likely to test with on the stream, it's gonna have a color table. and I know how many bytes it is because I've already looked that up. This block is optional. At most one may be present. It's in both versions. And it's literally just a bunch of bytes. RGB, RGB, RGB. That's easy enough. So this dot global color table equals new int 8 array global color size of global color table. That's not a very good name, is it? This should be global color table size, probably. Done. That's the global color table. Easy. Then what happens in the grammar? Maybe I should copy the grammar somewhere as a comment. Stick it at the bottom. Nope. What are you doing? Oh, it thinks it's XML. Ugh. What? Whatever. So after the logical screen, which is the descriptor and the color table, data star, data graphic blocks or special purpose blocks. Oh, we're already into the meat. Sorry. So how do I tell which one I've got? Graphic block. Okay, let's have a look at what an application extension looks like. Application specific information. Its block label is not XFF. Extension block syntax. That doesn't tell me a lot. Where will it? Okay, let's grab some bytes. Let's just grab some bytes and see what we're getting. Yeah, so after we're done with whatever we know how to do, let's just do the next 10 bytes. Because parse global color table. I need to return position plus this thing. Otherwise, I'm starting at 0 again. So my next byte is a 33 followed by a 255, not XFF. Okay, so does that mean this is an application extension? I was kind of hoping it wouldn't be. Okay, let's find in here. Application extension block, application identifier. That seems very application extension. Let's just look for application extension in here then. Sorry, extension block, extension block. block unless block label is not XFF. Maybe the extension introducer is the 33. Oh, okay. Extension introducer defines this block as an extension. This field contains the fixed value not x21, which if we look here, not x21 is 33. Okay. So I guess we have a bit of a branch. So after we've potentially got a global color table, in here we're into data star. We have 0 or more of these. So I guess what we're actually going to look for, let's find out what the trailer looks like. Because then what we can do is we can while loop over the data until we find the trailer. Then we can put in that check for the trailer now. And then we'll work on the actual blocks that come in between. So trailer. No. GIF trailer byte. This block is a single field block indicating it contains the fixed value not x3b. So while not this dot is trailer position this dot parse data position. Seems reasonable. I'm sure that'll come to bite me in the ass later. So here's trailer position. So what we're going to do is we're going to look. This feels wasteful. I know these things are cheap, but they're not free. Buffer position. There's probably a better way to do this. Return byte equals not x3b. Now, for the moment, that's an infinite loop because, well, if this parse data did exist, it wouldn't do anything. So, parse data position. I want to make sure. Well, you know, what's the worst that can happen? I'm going to just return position +1. And let's just see if this ends. I guess that's not very defensive, because what if the trailer is missing? Well, yeah, we'll read beyond the end of the array buffer. Okay, that needs to be more sophisticated. Oh, Ranger. Invalid typed array length 1. Why is 1 an invalid length? Really? What? Oh no, okay. This is exactly what I was talking about, isn't it? That we're reading beyond the end of the file. Yeah, success. Success. We're successfully reading bytes, and eventually we get to a point where that's invalid because we're reading beyond the end of the thing. That means we didn't find the trailer. Have I what is not X3B? Strained up from charcode. X3B. Oops. It's a semicolon. Oh. Okay, I spotted it. I don't want to be checking byte. I want to be checking byte 0. So there we go. It eventually finishes. So in fact, if I can put in a oh, this is now too big. A conditional breakpoint, we eventually get to that point, and at that point position is okay, 949 is probably not the end of the file, but there's just going to coincidentally be a not X3B in the middle there. Fine, let's parse some data. So in here it could be a graphic block or a special purpose block. And a graphic block might have a graphic control extension. So I need to be able to detect what the current situation is. So what I'll do is I'll just have it so that if I try and parse a block and it's not the right kind of block, I will just return the original position. We just won't move on, and then just round. No, that doesn't sound right. So there must be some way of determining which kind of block I'm looking at. So application extension, we decided extension introducer, which was not X21. The plain text extension also has an extension introducer. Not X21. Comment extension, same deal. So we can tell just by looking, at least for these, we can tell just by looking at a single byte what the next thing is. So an extension is going to have that not X21. What is that? Ah, an exclamation mark. Comment extension begins that way. Graphic control extension. Yes, same deal. Table-based image data does not start does not necessarily start T1. Hopefully local color table looks like it. Blah. Talk properly, mate. So table-based image data can only happen in a graphic rendering block. So if I and it starts with an image descriptor. So if I don't get an exclamation mark, okay, if I do get an exclamation mark at the beginning, then I'm either in an application extension or a comment extension, or I'm guessing a graphic control extension. I didn't actually. Graphic control extension 2.1. Yeah. If I don't get an exclamation mark, then I must be here. Plain text extension would also have it. table-based image, which starts with an image descriptor. So as long as an image descriptor can't start with an exclamation mark, then I'm okay. And I'm pretty sure since GIFs work, that is going to be the case. Field contains the fixed value not x2c. Which is a comma. So I look 1 byte in, and then from there decide which function to call. So const first byte equals new int 8 array. I should probably be using what is it called? An array view? Is it an array view? Rather than creating these new typed arrays. I'd forgotten about them. But another time, perhaps. Another time. Stop buffer. You know, I mean, coding is art, they say, and if you repeat yourself all over the place, I can just say I'm rhyming. It's a rhyme. It's more beautiful when I copy and paste the same bit of code over and over again. So if let's do that, so I don't make the same mistake as last time. In fact, we'll do it here as well. If I'm calling it byte, it should be a byte. So if first byte equals not x21, which, as we discovered, is a is this one exclamation mark? I think it was, yeah, exclamation mark. Which introduces an extension. We'll stick these in. Else if first byte equals not x2, was it 3 to C. Which introduces an image descriptor. What else could it be? So it's an extension, or it's an extension, or it's an extension, or it's an extension, or it's an image descriptor. They are the only things that it could be at this point. Nothing else. So, my else here, I can throw an error. Yeah. Now I know from our data that the first thing we're getting. Sorry, just lock that up a little bit. The first thing we're getting is an extension of some kind. It was the 255 kind of extension, application extension. I don't know what that might mean. So let's start parse extension position +1. Yep. So parse extension. Position. What's this going to be? It's going to be so the extension introducer was the Notex 21. So then we have the extension label. Yeah, definitely shouldn't be doing this every time, but there you go. This is the label. If label equals application extension. Just for the sake of completeness, I should check for the other kinds of label that are mentioned in the spec. I should have gone from okay. Comment label. Notex FE is a comment. Plain text extension. Okay, whatever that means. Sorry, that was F. I didn't actually like that's right. Oh, it's 01. Oh. So this should be where I throw my error. This error is unknown extension type label. Plain text extension. Do we have any other kinds of extension? Let's search for extension introducer. F9 is graphic control extension. This isn't super exciting at the moment. I kind of thought it'd be showing GIFs by now. Done that one. Done that one. Back to the beginning. Okay, that's all the kind of extensions we could have. And we got an application extension, which I'm guessing is something I can just ditch. I bet this is something I can just throw away, so what a waste of time. There you go. Let's find out what's in it. Application extension. Block size, brilliant. Oh, yeah, okay. This dot parse application extension position. Application extension position. Who'd have thought GIFs were so complicated? So the block size, Do all extensions have a block size? Maybe. No. No, apparently they don't. Good. So it can't bring the size out up here. So the size is this thing, exactly this thing. Const application extension. Oh. So the block size, number of bytes in this extension block, following the block size field, up to but not including the beginning of the application data. Ugh. This field contains the fixed value 11. That's not super exciting. Oh, we do have text. So maybe we do need a text decoder after all. Const decoder equals new text decoder. F8. So what I see is that, I mean, we can, if the size is always 11, then I don't care. So instead, we're going to skip that, and we're going to get the identifier. Const identifier equals, I don't need the size at all, just skip this. Identifier bytes. Flip. So it's position plus 1. That's 8, and we're not taking the first thing. And then we're going to console.log application decoder.decode identifier bytes. And this will tell us what application created the GIF. No, don't. Oh, no, it won't. Oh, yeah. Netscap. Netscap. Well, I mean, I don't believe you. And then it immediately goes, oh, that's because I'm now returning nothing, and it's going to try and read data from the beginning of the file. So return position. Yeah, there's a lot of refactoring that I would do to this code if refactoring wasn't going to be even less interesting than application extensions. We get the identifier. Apparently this was created by Netscap. Apple authentication code. Sequence of 3 bytes used to authenticate the application identifier. An application program may use an algorithm to compute a binary code that uniquely identifies it as the application owning the application extension. Well, that seems unlikely that 3 bytes could authenticate the application. I'm pretty sure encryption is harder than that. Let's see what's in there. This is going to be auth bytes. It's position plus 9. It's 3. Oh man, I mean, not that I don't want you guys to be able to see, but making this big is difficult. Okay, so Netscape E2, Netscape 2. This GIF was made with, I don't think this GIF was made with Netscape 2. So I wonder what software puts Netscape 2 as the application nowadays. Seems pretty unlikely. Netscape 2, that must be, that's like early 90s, some early 90s stuff going on there. Netscape 2 probably before JavaScript. How do the subblocks work? I just want to know. I basically just want to know how to skip this. I don't actually care about this part. So, application data subblocks. I just want to know how big you are. Data subblocks. Oh, a data subblock. Units containing data. Oh shit. Oh, so they contain a block size and then and then some data values. But oh, and then we go on until we get a block terminator, which is a 0, 0. Okay, next function, parse subblock. This one's more interesting because probably need to return the actual data here rather than the length. So this is going to return a uintate array, and then we'll work out the length, the new position based on the length. Or well, I can return an array. I can do multiple value return. So const subblocks is an array while how am I going to do this? So I need to read the next block, and if the block size is 0, stop. Okay, so I just keep going until the size that I get back is 0. Okay, so let size equals, or just let size, while size equals this dot parse sub block. It's not 0. No, that doesn't allow me to return 2 values, does it? What am I going to do? What am I going to do? I need to return something. I need to know the size. I need to know the contents. Just those two things, the size and the contents. And I want to wrap it all up in a nice while block. That's basically, that's going to be the thing I can't do, isn't it? Okay, so let size data equals this dot parse subblock position. While size is not 0. Subblocks.push data There we go. It's a little messier than I was hoping for, but that will do the job, I think. Yeah. Yeah. And for now, we don't really care about the subblocks, but let's see what's in them. Subblocks. So parse subblock. The length is going to be the first byte, just like we've been getting everywhere. This is going to be the length. Yeah, I can just so if the length is 0, then this does nothing, and that's really easy. So length, and I can just return length data. It's probably a little unnecessary to return to create that array if I know that length is 0. That is simple code. Okay, let's see what happens. Not the GIF. What happened is nothing with a no blocks. Parse subdata. Thanks, Soma, for useful information. Okay, dictionaries from returning multiple values. An array is a dictionary in JavaScript. They're the same thing. It's just overloaded to do something else. This is fine. This is fine. Yes, I need to do something with the position, but I don't know. Yeah, okay, you're right. So Zoma in the chat is suggesting that I refactor to make position be a state variable. So here, wherever I've got position, not wherever I've got position, I still need it in some places to be done. Get rid of it. And so all of these, where I now have this, you can go away. So that's going to be this dot position. This dot position. So start with this dot position equals 0. These functions will all update this dot position as well as using it. So that's going to be correct. Is trailer at this position, that's fine. This dot position. So returning 6, do this dot position plus equals 6. Don't take in a position. This dot position. Oops. This dot position plus what have I done? Plus equals 7. Come from there anymore. There. This. This dot position. Oh no, don't need to do that because the function will update itself. Ooh. So here, yeah, position plus equals 1. And that is we're going to be in the wrong place. Just that I know NYI, so not yet implemented image descriptor. Just that if I get to that, then I won't forget to implement this bit of code. Get rid of that. Get rid of that. Oops. That needs to have this. That can go away. It's quite therapeutic. Oh. Have I missed this whole function? Oh, I haven't. This dot position plus equals 1. Don't need to return. Doo-ba-doo-ba-doo. This dot position plus equals 12. Yeah. 9 plus 3 is 12. Yeah, and then these don't need to do that anymore. So while this, which can now return, while this not equals 0, oh no, that's let block equals it doesn't work. It still doesn't work because I still need to return two things: the data and the length. I mean, it's still more useful. I think there's still a good refactor, but it doesn't actually help in this particular case. Where are we? Okay. So I still need to do this. I just don't need to return the position anymore. Oh, let's see what we've got in the chat. Yeah, that's a good point about arrays versus objects with the destructuring. You can guarantee exactly what you're getting, but then I have to construct an object. Oh, that's very trivial as well, isn't it? Okay, let's do that. So we're going to destructure an object instead of an array, and then this returns. So it's exactly the same, except if I change these around. Oh, in fact, no, it's not going to be exactly the same because I've called this something different. Oops, I meant to get that one as well. Does that only work with let? Declaration or statement expected. What have I done wrong? I don't think you can destructure it in the same way. Yeah, I thought this would work too. I mean, it does look kind of wrong when you do it. So when it works with the let case, I guess it's a grammar thing, because this could be a JS block with a single expression in it. Sorry, a single statement, and that statement is two variable expressions and the comma expression, the comma operator joining them. So this is actually valid code, like even in like ES3. It wouldn't do anything, but it's valid code. It's a block of code. So how do you differentiate whether this is a block or an assignment? I mean, the equals, obviously. No, it could still. It might be an ambiguity problem. Okay. It was a nice thought. And getting rid of all that position nonsense, I think, is going to help. And at the end here, we'll have we'll always have the empty block, which actually has a length of 1 because it has the 1 byte length. And here, this dot position, this dot position. Now what are we getting? This is suggesting to me that we don't actually have any subblocks. Stars not equals 0. Yeah, so this file doesn't actually contain any of that nonsense. Oh, Chrome DevTools, what's wrong with you? What is wrong with you? Where's my code? Where's the codes? I don't like working with this when it's so big. Ah, kill it. That was interesting. Oh, I have an infinite loop. I've seen this before. So here I'm just going to throw an error because that will stop it. Yeah, it's going to grab it from the cache every time and everything. So it's really hard to get around an infinite loop because when you reload the page, it grabs the old version from the cache. Ah. Okay. Yeah, okay. Zema has a tip in the chat about how we make the object assignment work, but I have issues to deal with right now. Okay. I've crashed DevTools like this a lot, and there isn't really a great way to do this. But if you inspect before you open the page, you at least have DevTools available to you. So let's pause script execution, I guess. No, that's not going to do me any good. Oh yeah, so here's why it helps, because in here I can say disable the cache, and now it will actually give me my a different error. but we're no longer loading from the cache, so we don't have the version with the bug in, which is handy. What's how do I okay. Position is not defined. Reference error. Oh, yeah. That's right, because we undefined it. This isn't... So I put in what I thought should be an error that happens every time, and we're still not seeing gif.js. Are we in an infinite loop again? What's going on? I'm expecting it to do this, and then error. Oh. This must be... This must be where we have our problem. God damn it. I code infinite loops all the time. All the time. You'd think that it wouldn't be the sort of thing that someone who knows what they're doing would get themselves into. And I think that just tells you that I don't know what I'm doing. Because I get unquote in promise error. Good. I get myself into infinite loops all the time. So, size 177. So there's actually a whole bunch of data here. It looks like it might be... It's sort of in the range to be ASCII. 32 would be a space. Long word if it's word there. I wonder what it is. Decoder.decode data. Well, it's not text then. Who knows? Some garbage, probably. As we said, I don't even need the application extension. I just need to I just need to skip the data. So okay, we won't do that then. We'll stick a thing here. Size is 48, and we have some data. What is that data? I don't know. Some junk. Size is 177. There's some more data. Some more junk. Size is 177 again. Is that the same thing? Am I not updating? I don't update. Oh no, this parse subblock never updates position. It never updates position. So that's why I have an infinite loop. This is just going to parse the same thing over and over and over again, because here I do that. It means I don't need to do it there. Oh, what now? Oh, okay. No, it's fine. It's fine. It's fine. Don't panic. Paused on breakpoint. I just can't see anything in this with the. I'm sorry, people on the stream, but I'm just gonna make this small again, just so I can find where I am. It says I'm paused on a breakpoint. Are you telling the truth? I'm not, am I? It's an infinite loop again. Oops. No, that was incorrect. It just gets me to infinite. I need to inspect. Let's put that error back in. There we go. So we get a 48. Fine. Oh, yeah. Okay, I'm struggling with basic editing right now. So we have a 48 byte block, we have a 177 byte block, a 27 byte block. What's in that one? More junk. An 88 byte block. Guess I'm up to 49, 109. Tons and tons of data in here. What's happening to position? It is going up. Wow. So there are 177 blocks of data, and this seems to be like what is an application extension? Why is there so much? Why is there so much stuff in there? Application specific information. It doesn't seem like there should be all that much in there. I mean, what even is it? The spec does not say. There's a whole bunch of data we can ignore. It seems like I've fixed my infinite loop somehow. Or at least there. After here we probably go back up to... Oh no, we get the error. Yeah, I guess if we get one of these, that's going to cause an infinite loop. So I should do similar here. Oops. Where I'm going to throw an error if it is one of these, just so I know which one to implement next. So this is going to be comment. Graphic control. Main text. So let's see what we get next. Unknown block type. Unknown block type. Oh. So you can't do that. So we're not seeing what that first byte is because error doesn't take a second argument like console log does. We'll deal with the others when we get there. Unknown block type 65. That's an A, pretty sure. Oh, I should make this big again so you can see it. Yep. So, what? Unknown block. So we're getting here. So we're parsing the first extension, which has way more data in it than I think should be there. So maybe I'm running over the end of that block. Maybe I'm not stopping when I should. It's a possibility. Oh, maybe I'm mishandling the end of the block. Maybe that isn't the end of the application extension. Block terminator. What is a block terminator? Is that just the 0 for the application data? I think it's just the zeros. Yeah, because otherwise, I don't know. So what do we get next? What are the next bytes? So the header is fine. Probably not updating this dot position properly somewhere. That's going to be my theory. We might be reading the same data over and over again. This might be wrong. 8 and 3, it's 11 bytes. It's maybe I shouldn't be adding 12 here. Pause application extension. So we're reading the label, and I'm not updating position. So let's do that. So I get the reading the label, and in here, the next 8 bytes, let's confirm that, the next 8 bytes after the label, there's the application extension. No, there's a block size. Okay, so the first of all is the block size. I'm going to read it just so that I have it written down in the code. So that I remember it's there. So this is 0, it's just 1 byte from the start position. So that's why this is this dot position plus 1. So this comes out to be 11 always. So then you've got these 11. So yeah, it really is plus 12 here. The length, the identifier, the auth. 1 plus 8 plus 3, 12. Now pausing the subblock is not actually moving anything along. But we update it here. So it's the size plus 1 because of the actual length written in there. We read it at least once. If the size is 0, then that's the only time we read it. Then we update size and data and move along further. So again, if this one updates the size, it's a real block, and then this one the size comes back as 0, we're just adding 1, size will be 0, and we're done. So I don't think I have a problem there. I think we really are reading the application extension correctly. It's just a lot of it, and it seems unnecessary. First byte is not defined. What? Where? Oh. Oh, that's exciting. I think I fixed a bug without spotting it. I don't know what I changed. Because I've moved on to something new. Oh, goodness sake. No. I'm failing at keyboards right now. Failing at using a keyboard. Okay, NYI, graphic control. Yay! So we are getting on to the next kind of data, which actually is going to have some graphics in it. Graphic control extension. Or maybe not. So, here's what I'm thinking. I'm going to do this one more block. And then I think we'll wrap up. And I appreciate that this hasn't been super satisfying. Maybe this is why everyone else prepares their streams better and has a bit better idea of what their finished. Most people would have read the spec and understood how to implement this before they started. And I thought, let's go through that process. I don't know if this is interesting to everyone. So what I think I'm going to do is I'm going to implement this block. Have a think to see if there are any questions that you might want to ask about anything. Stick them in the chat on YouTube. And if there aren't any, then we'll call it there. And let me know if people want to see me finish this on another stream. And I'll certainly share the code at some point. Okay, let's before that, let's finish this next block. This doesn't seem very difficult. So this is the graphic control extension. This.parse graphic control extension. You can see actually in the application extension we get subblocks and I console log it, but I don't actually store it or use it or anything. Just don't care because the spec doesn't tell me what that is. It's something that whatever application created the GIF has added in, and it was like 7K, something like that. 7K of data. What a waste. Parse graphic control extension. Oof. No. There we go. So we're past the extension introducer, and we're past the label. We do that before we even get into this function. So let's delete those. So we're going to get the block field, the block size, which is exactly the same as this. Oh, this one is this is a fixed size. The block size is presumably going to be 4. Is it 4 or 5? Does the block terminator count? Let's have a look. Block size. This field contains the fixed value 4. Lame. So then we have fields. Delay time, which is 16. And transparent color index. I definitely shouldn't be making new typed arrays for every single one of these. That is definitely wrong. So +0, +1, +2, +4. Yeah. That one's not fields. That one's delay time. Now, what do I do with this information? What is this information? So I guess we're creating a graphic, because there could be more than one of these in the stream. Used when processing a graphic rendering block. The scope of this extension is the first graphic rendering block to follow. This extension contains only one data subblock. Okay, so this is going to return the block. which is then going to be it needs to be passed up back the chain so that the next time I read a graphic, I've got the block extension information. What are the fields? Oh, packed fields reserved. Well, that's fine. Disposal method. Const disposal method. This is 3 bits, starting at bit 2. So we're going to take fields. We're going to end it with so 1, 2, 4, 8, 16, 24, 28. No, hang on, no, wait. 1, 2. It's A? No, B. Oh, okay, hang on, let me... Rather than doing hex math in my head. So we're going to do 4 plus 8 plus 16 as a number object to string 16 1C. Not X, 1C. So that gets us, that masks off the fields. Oh, what have I done now? And then we shift it back down by 2 to get the number in the right place. Okay, const user input flag. It's a single bit. Responding to 2, and then transparent color flag. Because I said I was going to return the graphic control, I basically need to create all this in an object. Return all of this. Boom. Wait, this one needs to be separate so I can refer to it. And also I don't need to return the actual value of this. Going to put it in a value so that I can return it after I update the position. Which is going to be 6. Yeah, so the size of the thing is officially 4. But I've got the size and the terminator, so 6. And I guess let's log the result, see what we get. So what I expect to see here is a log of this result and then another error saying that I haven't implemented the next thing. Hopefully image descriptor. I think that's what should be next. So we should see NYI image descriptor. NYI image descriptor. Perfect. and our object. Why can't I move? Why can't I move this? Oh, okay. Ah, there we go. That's better. So I don't know. I don't know exactly whether these things are correct. Transparent color flag. Did I set that? Is that really one of the things? No. Where have I've copied transparent color flag from somewhere. Transparent color index. Oh no, transparent color flag. Yeah, okay, fine. Yeah, that is correct. So, I'm parsing a GIF. I've got some way through parsing it. It was a disappointingly long time to get to this point. The application extension nonsense. I wish the file I found hadn't had it, so that we didn't have to do it first. Because I think the very next thing we're going to do, let's have a look, the image descriptor tells me about all of the images in the file. So it's got the position within the canvas, and the width and the height, whether it's going to use a local color table. Then that is followed by the local color table if there is one, and then the image data. The local color table, I bet, is exactly the same as the global color table. So we already have that function. I'll just change it to be parse color table, and it return the color table. That'll be grand. Yeah, so this close to having image data, but sadly not today. So let's have a look in the chat. I don't see any questions in the chat, but I am at WibblyMatt on Twitter if you want to ask me about it again, or if you want to make any comment on this. The video should be up on my YouTube channel shortly after this. I think when I stop the stream, YouTube will crunch away and turn it into a video that's hosted on the site. Which means you might not be able to see it for a little while in between, but presumably you can watch it on the DVR up until the end of you should be able to continue watching it on the DVR until you finish watching. So yeah, if you have any comments, let me know on Twitter or in the comments on the video, yeah, let me know what you thought. So, good night.